All right. Well, happy Monday, Honors Algebra 2. Got some things I want us to look at today about solving radical equations. So, first off, let's talk about your step by step. So, step number one, if possible, we want to isolate the radical on one side. So, basically, get your square root or your cube root, whatever it might be, by itself first. Step two, you're going to raise each side of the equation to the same power as what the index is. So if it's square root, you raise the power of 2, cube root 3, and so on. And then step three, you're going to have to check your solutions for extraneous solutions. Now, unlike with rationals, we're not going to have a restricted domain, so you're going to actually have to check your answer by plugging it back in. There's really no way around it. So let's see how this works. Let's take a look at number one here. So on number one, you've got 4 radical 2x plus 1 equals 12. So step one, get the radical by itself, divide each side by 4. So we've got radical 2x plus 1 is equal to 12 divided by 4 is 3. All right. Step two, raise each side to the same power as out of the index. So if it's a square root in this case, we're going to take each side and raise it to the power of 2. That way on the left side, square root and square cancel. You get 2x plus 1 is equal to 3 squared, which is 9. Now we're just going to continue to solve it. So we would subtract 1 from each side. 2x equals 8. Divide each side by 2. X equals 4. All right. So here's what you have to do next. Is we're going to actually have to check our answer by plugging it back into our original equation. And the original equation. So before we've done anything to it, that's where we have to plug it in to check. So here's what that would look like. We'll start to simplify now. So 2 multiplied by 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. There's 4 multiplied by 3 equals 12. And yes, 12 equals 12. So that's the correct answer. Okay, let's move on to number 2. So number 2, we've already got radicals by themselves on each side, and they're both cube roots. So we take each side to the power of 3. That way cube root and cube are going to cancel. So we get the 9x plus 1 equals 11 plus 8x. Okay, so now let's start to solve. We'll subtract 8x from each side. That gets us x plus 1 is equal to 11. And we'll subtract 1 from each side. So x equals 10. And now we just have to double check that. So cube root of 9 multiplied by 10 plus 1 equals cube root of 11 plus 8 multiplied with 10. And then we'll take cube root of 90 plus 1 equals the cube root of 11 plus 80. So cube root of 91 equals cube root of 91. And at that point, we're good. Okay, moving on to number 3. So we've got 4x minus 2 to the power of 1 half equals the square root of x over 5. So you can do this a couple different ways. You could first rewrite 4x minus 2 to the power of 1 half as the square root. Remember that would just be using the rational exponent property that we talked about on Friday in class. You can also just raise each side to the power of 2. Because if you think about what's going to happen, 4x minus 2 to the power of 1 half to the power of 2, 2 multiplied by 1 half is 1, so this cancels. Also on the right side, square root and square cancel. And now we've gotten rid of kind of everything we needed to. So we've got 4x minus 2 equals x over 5. At this point, what I would do is I would get rid of the fractions, multiply each side by 5. So then that becomes 20x minus 10 equals x. All right, so let's keep solving. Negative 10 equals negative 19x. And then divide, so x equals 10 over 19. Okay. Just for the sake of time in this video, I'm going to leave it to you guys to check this answer. it does in fact end up working, but just for the sake of time, I'll leave that up to you guys. Let's take a look at number 4. So number 4, we've already got the radical by itself, so you can square each side. Here's where it would probably be best to put the right side into parentheses. That way you remember to distribute everything. Okay, so left side we just get 3x plus 4. Right side, if you take x minus 2 squared, which is the same as taking x minus 2 multiplied with x minus 2, you're going to end up getting x squared minus 4x plus 4. Alright, so because it's quadratic, let's get one side equals 0. I'll do that by subtracting 3x and subtracting 4 from the left side. So 0 equals x squared minus 7x. Okay, so now let's go ahead and solve. The easiest way is to solve by factoring. And now we can go ahead and say what our two solutions are. So x is 0 and x can also be 7. Alright, so now let's check both of those, make sure they're both good. So we've got 0 first, the square root of 3 multiplied with 0 plus 4 equals 0 minus 2. So the square root of 3 multiplied with 0 is 0. 0 minus 2 is -2. So we get the square root of 4 equals -2. But the square root of 4 is 2. And 2 doesn't equal -2. So that means that 0 is an extraneous solution. We'll do the same thing we did for rationals. We'll just circle it, write EXTSOL, just meaning that it doesn't work in our original equation. Let's check 7, see if we at least have one solution. So 3 multiplied by 7 plus 4 equals 7 minus 2. So that's the square root of 21 plus 4. 7 minus 2 is 5. Square root of 25 equals 5. And for this one, it does end up working. 5 does equal 5. So x equals 7 is good. 0 does not. Alright, 2 more. Let's work through them. So on number 5, we've got x equals square root of 2x minus 1. We can go ahead and square each side. So left side, that's x squared. Right side, 2x minus 1. Then let's get equation equals 0. So we would subtract the 2x, add the 1. So x squared minus 2x plus 1 equals 0. And then from there, we'll go ahead and solve by factoring. So x minus 1 equals 0. And so x equals positive 1. Notice that we're not going to say anything about multiplicity here. You really don't get multiplicity with radical functions. So while you might be thinking x equals 1 multiplicity of 2, that really only applies to polynomials. However, we do need to still check our work. So let's do that now. Put 1 back into the original equation. So 1 equals the radical of 2 multiplied by 1 minus 1. So 1 equals 2 minus 1. So 1 equals the square root of 1. And yes, 1 does equal 1. So we are good there. Okay, one more to go. Let's take a look at it. So number 6. Notice that the first thing we need to do is get the radical by itself. So we need to add the x over to the right side. So square root of x minus 3 equals positive x minus 3. Now that we've done that, we can go ahead and square each side. So left side, that becomes just x minus 3. Right side, don't forget you'd have to multiply that out. Will become x squared minus 6x plus 9. Okay, so now let's solve for x. Let's do that by making the left side equal 0. That means that we would subtract over the x to get a minus 7x, add over the 3 to get a plus 12. And then probably the easiest way to solve would be, once again, factoring x minus 3, x minus 4. So then we're going to get two solutions, x equals 3 and x equals 4. Alright, let's check and see if they both work. So starting with the 3, we'll take square root of 3 minus 3. Minus 3 equals negative 3. So 3 minus 3 is 0. Square root of 0 is 0. And negative 3 does in fact equal check the 4 now. So 4 minus 3 minus 4 equals negative 3. Becomes square root of 1 minus 4 equals negative 3. Square root of 1 is 1, so 1 minus 4 equals negative 3. And negative 3 does in fact equal negative 3. So yeah, we're good with both of those answers. Alright, I believe that's all I've got for you guys. That is solving. Should be pretty quick and easy for you. Their homework is on Big Ideas Math today. And then all of those homework assignments, both from last week and from today, remember, going to be due on Tuesday by 4. So I will be back on Tuesday to go over those with you guys. But yeah, just make sure you're getting ready for that, and I will see you then.